This is the video for section 7.2, and this is going to be part 1. And we are solving systems of equations with 3 variables. So you can notice our equations are now going to have 3 variables. In this case, we have an x, a y, and a z. If I graph that, you can see we get a 3-dimensional graph. We won't be doing that, but you can notice that we're going to need 3 lines, and it's going to be where the 3 lines cross. So we're trying to take 3 lines in 3 dimensions and see where they cross. In order to do that, we have to have 3 equations with 3 unknowns. When we had 2 unknowns, we needed 2 equations. 3 unknowns, 3 equations. We're going to be using a lot of elimination here. We're going to start by picking a pair of equations and eliminating 1 variable to get it down to just 2 variables. And then we're going to do the same thing again, so then we're going to turn out to have 2 equations with 2 unknowns. So our goal is to get this down to 2 equations with 2 unknowns. I'm going to number my equations 1, 2, and 3 just to help as we're working through them. We'll refer to different equations along the way. Now, I'm going to pick 2 of those equations, and I'm going to start with equations 1 and 2. And I'm going to pick a variable to eliminate. Now, I can pick any variable I want. I'm just going to eliminate the z. Now, to eliminate the z in equations 1 and 2, I'm going to have to multiply equation 2 by a 2. So equation 1 is going to stay the same. And equation 2 is going to turn into 6x plus 6y plus 4z equals negative 6. Now, when I add these together, I get 11x plus 4y. The z's are eliminated, equals negative 3. So I'm down to an equation with just 2 unknowns. I'm going to pick a different 2 equations. This time I'm going to pick equations 2 and 3. And I'm going to eliminate the same variable. I'm going to eliminate the z again. Now, in order to do that, I'm going to have to multiply both equations by something. I'm going to multiply the top equation by a negative 3. So I'm going to have negative 9x minus 9y minus 6z equals 9. And I'm going to multiply the bottom by a 2. So I'm going to have a negative 4x, a positive 10y, a positive 6z, and a 6. Now, when I add these 2 equations together, I get negative 13x plus y. The z's get eliminated, equals 15. Now, the nice thing is I have 2 equations with 2 unknowns. So I'm going to rewrite those. And I can now solve this system of equations with 2 unknowns by using the methods we learned in 7.1. I'm going to go ahead and take that bottom equation and multiply by a negative 4. So I'm going to rewrite the top one the way it is. I'm going to multiply this one by a negative 4 to eliminate the y's. So we're going to get 52x minus 4y equals negative 60. And now when I add these together, I get 63x equals negative 63, so x is negative 1. I just found one of my variables, negative 1 for x. I can plug it back into one of those 2 original equations. Let's pick the top, the 11x one. So I get negative 11 plus 4y equals negative 3. I'm going to add 11, so 4y equals 8 and y equals 2. Now that I have x and y, I can find z. I just have to take the x and y and plug it into any of my originals from the very, very top. So I'm going to go ahead and plug it into the very first equation, 5x minus 2y minus 4z equals 3. So 5 times negative 1 minus 2 times 2 minus 4z equals 3. So you can see I plugged the x and the y in, and now I'm going to solve for the z. So negative 5 minus 4 minus 4z equals 3. Negative 9 minus 4z equals 3. So negative 4z equals 12 when I add 9 to both sides. And z is negative 3. So now I've found my x, my y, and my z. And we like to write it as an ordered pair, x, y, z. So we get negative 1, 2, negative 3. And that would be my answer. If we just look again and see what we did, we picked 2 equations and eliminated one of the variables. We picked a different 2 equations and eliminated the same variable. I was down to 2 equations with 2 unknowns, and then I just solved that system and kept plugging back to get the final answers. Let's go ahead and look at another example. We'll just do 2 examples today because they're quite lengthy. We have x plus z equals 8, x plus y plus 2z equals 17, and x plus 2y plus z equals 16. So here's equations 1, 2, and 3. Now, the nice thing about this one is if you look at equation 1 for a minute, if we look at equation number 1, you can see that we only have 2 variables here. We just have 2 variables, just an x and a z. So I'm going to pick these other 2 equations, and I'm going to eliminate the y. If I do that, I'll be down to just the x and the z, and then I can go from there. So I have one less step this time. So let's go ahead and pick equations 2 and 3. And this time, let's eliminate the y. So we have x plus y plus 2z. To eliminate the y, I'm going to have to take that first equation and let's multiply by a negative 2. And equation 2 will multiply by negative 2. So we get negative 2x minus 2y minus 4z equals negative 34. And we'll leave equation 3 the same. Now when I add these together, I end up with a negative x, a minus 3z equals negative 18. Now I have an x and a z, and I can use that with equation number 1. So we'll rewrite equation number 1, x plus z equals 8, with the equation I just got using elimination. And the nice thing is, if I add these together right now, those x's are going to cancel out. I get negative 2z equals negative 10. So z is 5. Now that I found z, I can plug back in to find x. So x plus 5 equals 8. I'm going to use the first equation. So x is going to be 3. And now that I have x, I can go back all the way to either equation 2 or 3 from the start, and I can find y. So I'm going to use the second equation, and I'm going to have 3, because that's x, plus y, plus 10 when I multiply 5 times 2, 5 times z, equals 17. So y plus 13 is 17. And y is going to be 4. So my solution is 3, 4, 5. You can see that these problems have a lot of algebra involved, so there's a lot of places to make some little errors. All right, this is where we're going to end the video for today. We're going to get to practice these tomorrow.